So, in this lecture, we will just have a brief review of what we have done so far. So, we have already defined what is a random variable. We looked at discrete and continuous random variables, how these arise naturally in a lot of applications, and then afterwards we introduced what is called a probability mass function. That is, when we want to know about the distribution of a random variable, we represent the distribution of a discrete random variable with what we know or what we call the probability mass function. We also saw that the probability mass function, the graph of a probability mass function gives us an idea of the distribution of the random variable. We also introduced the notion of a cumulative distribution function, which also helps us to understand how a random variable is distributed in a complete range. So, now we are going to introduce an extremely important concept of a random variable, which is called the expectation of a random variable. So, we first go and look at an application of the concepts we have learned so far. Suppose we are interested in analyzing the number of credit cards owned by people or adult population in a particular geographical area. Towards this, we collect data on a number of people, and the data we have collected on them is we ask them, or what we record is the number of credit cards that they own. So, if I am looking at it as a random experiment where I am choosing a random or a person from this collection of people, my random experiment is to select an adult at random. So, it could be one, I am selecting an adult, I just note down the person's name, I am selecting another adult. So, if I am selecting 50 adults, my sample space is going to be each one of the adults whom I have sampled from this population. Now, associated with each adult, so I have a sample space. For example, my sample space could be Raja, it could be Bharat, it could be Andrew, and so forth. All these people whom I am sampling, it could be some, then after it could be Maithili. I could just write down all these people. Associated with each outcome is the number of credit cards owned by the person. So, Raja could respond by saying that he owns 4 credit cards. This person could say no, this says no, 0, this says 1. So, associated with each outcome, I am defining the random variable, which is the number of credit cards owned by the person. So, I can see that when I am looking at number of credit cards, this number is a discrete random variable. So, let me denote that by x. So, x is the number of credit cards owned by a person. Now, this takes discrete values because I cannot own 1.5 credit cards, I can own it in discrete values, and the values I can see that this takes are the following. I can own 0, a person has either owns no credit card or 1 credit card or 2 credit cards or 3 credit cards or 4 credit cards. So, that is the value that this random variable x takes, which is 0, 1, 2, 3 and 4. Now, this random variable takes these values with a particular probability. I can see that it is 0.42 with that now x takes the value 0 with a probability 0.42, 0.36 it takes the value 1, it takes the value 2 with a probability 0.14, takes the value 3 with a probability 0.06 and 4 with a probability 0.02. I can verify that this is a probability mass function. I add all of them and I can see that this is 0.50 plus 0.50, which I get is equal to 1. Hence, this is a probability mass function, further everything is greater or equal to 0. So, hence I have a probability mass function which is given to me. Now, let us plot the probability mass function. The minute I plot this probability mass function, this gives us the distribution of the random variable. So, you can see the graph of the probability mass function. The probability mass function, the distribution, remember we said the probability mass function tells us about how this random variable is distributed. We can see that the 0 has a peak. When we say 0 has a peak, this says that I can expect that most of the people do not own any credit card, and then afterwards I see that many people own one credit card, whereas very few people own 3 and 4 credit cards respectively. So, you can see that this probability, this table, that is the probability mass function, gives us an idea of the distribution. So, as an application, let us look at describing the distribution. Again, if you look at this distribution, you can see that it is peaked at 0 and then followed by 1, then followed by 2, then followed by all the other values. So, you can see that there is a skew to this distribution. Again, recall, I say a distribution is symmetric if it is of this kind. We have seen a symmetric distribution. It is skewed, it could be either skewed this way or it could be skewed in this way, and we can see that this particular example exhibits a skewness where I have a peak at the lowermost value and it is tapering down. So, I can see that if I am asked to describe the distribution, I can say that it is skewed right with a peak at 0, and the values of x are 0, 1, 2, 3 and 4, which I can further articulate by saying that the number of credit cards owned by people vary between 0 and 4. So, now let us use this information to answer a few questions, because finally data analysis is about extracting information from the given data. So, how do I use this information? I choose an adult at random. Is he or she more likely to have no credit cards or 2 or more credit cards? Now, how do I answer this question? I know X is the total number of credit cards. So, to answer this question, that likely to have no credit cards, I am looking at probability X is equal to 0. 2 or more credit cards, I am looking at the question probability X is greater or equal to 2. Now, what is probability x equal to 0? We can go back to our distribution and see that the probability x equal to 0 is 0.42. Probability x equal to 0 is equal to 0.42. This comes from my probability mass function. Now, probability x is greater or equal to 2 is the same as probability x equal to 2 plus probability x equal to 3 plus probability x equal to 4. Probability x equal to 2, again we go back to our distribution, it is 0.14, this is 0.06 and 0.02. So, I can see that this probability x equal to 2 is 0.0. So, we can see that probability x equal to 2 is 0.14 plus 0.06 plus 0.02, which is equal to a 0.22. I know 0.42 is strictly greater than 0.22. So, I can say that an adult is more likely to have no credit cards than own 2 or more credit cards. So, that is very clear from the distribution table itself, because the peak is at x is equal to 0. Now, let us look at another question which we are trying to answer from here. The next question we are trying to answer is, you take a random sample of 500 people and you ask them how many credit cards they own. So, let me rewrite the distribution. X takes the value 0, 1, 2, 3, 4. The probabilities are 0.42, 0.36, 0.14, 0.06 and 0.02. Okay. So, this adds up to 1. This is my probability x equal to xi. This is the probability distribution I have. Okay. So, now would you be surprised at the following? What is the first thing? Everyone owns a credit card. So, if I take 500 people, my distribution says probability x equal to 0 is 0.42. In other words, the way I can interpret this is, in the sample of 500 people, that the chance that people have no credit cards is pretty high. So, if everyone owns a credit card, then it would be unlikely, because 42% of the adults do not own credit card according to my distribution. Hence, it is very unlikely that every one of the 500 would own credit cards. So, this, if somebody is claiming that everyone owns a credit card, I would look at it with suspicion, because my distribution says that 42% do not own a credit card. The second question is, 72 people respond that they have 2 credit cards. Okay. So, let us go back. I can see that the probability x equal to 2 equal to 0.14. I have 500 people. So, if the chance of a person having 2 credit cards is 0.14, among 500 people I can expect 0.14 into 500, which is equal to 70 people. From 500 people own 2 credit cards. That is what my probability distribution says. The statement says that 72 respond. So, I would not be surprised, because 40% of 500 is 70. So, it is likely. The first case, it was unlikely that everyone would own credit card, whereas here it is very likely that 72 people from a sample of 500 own 2 credit cards. So, the next thing which we are going to see is, if I choose an adult at random, how many credit cards would I expect this person to have? So, you see, I am qualifying this word expect. We need to understand what we are meaning, what do we expect from this statement. So, now we are going to introduce what is an expectation of a random variable. So, at this point of time, you should know what is a random variable. We are looking at a discrete random variable. A discrete random variable can take finite number of countable values or infinite number of countable values with their respective probabilities, probability x equal to x1, probability x equal to x2 and so forth. We have defined the properties of a probability mass function. All the probabilities, the sum of the probabilities should add up to 1 and they should be greater or equal to 0. These were the 2 key properties, and then we talked about the graph of a probability mass function. We introduced the notion of a cumulative distribution function, and we looked at how do we answer questions about the distribution of a random variable through an example based on credit cards.